Welcome to my second video about atoms for folks studying chemistry at National 5 level. Now, chemistry is what we call a cumulative subject. What that means is that you have to know some basic stuff before you can understand and learn more advanced stuff. So I'm going to assume you know some things before I start. I'm going to assume that you know that atoms have a nucleus, the central bit of an atom. I'm going to assume that you know that the nucleus is positively charged. Now, all you need to know about that is that it means it will attract negatively charged things and repel positively charged things. You should also know that atoms also contain negatively charged particles called electrons that orbit the nucleus. Now, the nucleus is incredibly tiny and electrons are even tinier. That means that almost all of the volume of an atom is empty space. Now, I'm assuming you know all that. If you have any doubts about any of that, please go back and look at my first video. I'll leave a link in the comments below. Okay, I'm going to tell you about something now that doesn't really come into the syllabus, but I kind of like it. Back in 1911, a guy called Robert Millikan was doing a really fiddly experiment with charged oil drops. Do look it up, it's quite a brilliant experiment. And what he found was that these charged oil drops didn't just have any old amount of charge. He found that the charge came in multiple amounts. That the charge could be 1 times, 2 times, 3 times, 4 times, whatever, that certain amount of charge, but nothing in between. And what he worked out was that these charges corresponded to the oil drops having gained 1, 2, 3, 4 electrons and so on. So each electron is associated with one lot of this negative charge, which we are just going to call 1 negative. Right, let's go back to our picture of an atom. Atoms are neutral. They're not positively charged, they're not negatively charged. And yet they contain electrons, and we now know that each negative charge comes with a particle, an electron. So the total negative charge of those electrons has to be balanced by an equal positive charge. We also know that the positive charge of an atom is concentrated in the nucleus. The positive charge then also comes in the same size chunks as the negative charge. So the nucleus has positively charged particles. Let's look at what that's about. Let's take an atom. This is just going to be the nucleus. There you have a positive charge in the middle. 2 positive charges, that would require 2 electrons. So an atom with 2 electrons, a helium atom, must have 2 protons. 3 protons, that would imply an atom of lithium, and that atom would have 3 electrons. 4 electrons, that's an atom of beryllium, and that atom would have 4 electrons. And 5, that's boron, 5 protons in an atom of boron, and 5 electrons to go with it. These particles then are protons. But that's not the end of the story as far as the nucleus is concerned. Each atom has a certain number of electrons, right? For each electron, there must be a proton in the nucleus to balance the charge. So, take a hydrogen atom. It has 1 negatively charged electron orbiting the nucleus. So there must be 1 positively charged proton to balance the charge. The thing is, though, that the masses of atoms show that there must be something else. Take a helium atom, for example. It has 2 electrons and therefore 2 protons. But the mass of a helium atom isn't twice as big as that of a hydrogen. It's 4 times heavier than that of a hydrogen atom. It's almost as if there must be extra protons, but there can't be. But there must be other massive particles. These were discovered by James Chadwick in 1932. They are neutral, they have no positive or negative charge, and they're called neutrons. So let's see how that pans out. Let's take a nucleus, right? Now I know a nucleus doesn't really have an edge. I'm just drawing a nice circle to show that what's contained in that circle are the particles of the nucleus. Right, let's take an atom of hydrogen. An atom of hydrogen has 1 proton and 1 electron. No overall charge. It has no neutrons. So the mass of a hydrogen atom consists simply of the mass of that 1 proton. We're ignoring the mass of electrons because they have virtually no mass. Okay, let's now go to helium. Now, helium has 2 protons and 2 electrons. But that would simply mean double the mass of a hydrogen atom. And as we said before, the actual mass of a helium atom is 4 times bigger. So there must be 2 other particles in there to increase the mass. And there they are, 2 neutrons. That now has a nice mass of 4, which is what we want. Okay, now consider lithium. Lithium, 3 protons, 3 electrons. But we know that the mass of a lithium atom is 7 times heavier than that of a hydrogen atom. So to get 7 times heavier, we're going to need a total of 4 neutrons there to give us that total mass of 7. Now, we need to define some words at this point. Atomic number. That's the number of protons in an atom or ion. Yes, I know we haven't got to ions yet, but we will do eventually, and we'll need to know this definition at that point. So atomic number is the number of protons. Incidentally, that is the same for every atom of a particular element. Every atom of a particular element has the same number of protons. So every carbon atom in the whole universe has 6 protons. If an atom does not have 6 protons, it's not carbon. There's mass number. That's the number of protons plus the number of neutrons. Effectively, it's the mass of the atom, because we ignore the electrons because they really don't weigh very much at all. Therefore, the number of neutrons in an atom must be the mass number, take away the atomic number. So, where does that get us? First of all, the nucleus of an atom is made up of particles called protons and neutrons. The protons are positively charged. The number of protons in an atom is equal to the number of electrons. Has to be, otherwise the atom would have an overall charge. Neutrons are uncharged particles in the nucleus. They make no difference to the overall charge because they are neutral. Now, the number of neutrons in an atom is the mass number, take away the atomic number, where the mass number is the number of protons plus the number of neutrons, and the atomic number is simply the number of protons. That's it for just now. Thanks for watching. Bye just now.